Hello everybody, hope everybody is doing great. CRS here. In this video, I'd like to speak to you about how much time it takes for a certain thickness of a layer of ice to form. It has been millions of years since Earth has been going through a lot of changes in its climate. There are places, for example, North Pole and South Pole, where there is kilometer thickness of ice. There are some subtle questions that we need to answer today. Why didn't the fish inside these places underwater, when the water froze, why did not all the water freeze, and why did it not mean death to all these aquatic beings? Let's try to find out today. Mathematically, let's begin and find the amount of time it takes in order for a certain thickness of a layer of ice to form. So here I've got a nice picture of a lake for you. So this is the surface of the lake, and let's assume that the thickness of ice that has already formed on the thickness on the lake is y. Y is the thickness of ice that has already formed. The temperature outside is minus T degrees Celsius. So it's quite cold outside. The temperature is minus T degrees Celsius. Let's assume that water in here is at 0 degrees Celsius. Okay. When compared to that, that is T degrees Celsius lower. Now, I'd like to talk about the thickness of ice that has increased just now by an amount dy. Dy is this pink color portion that you see that has just now formed, and its thickness is dy. If you ask me how much heat would that layer of water would have lost in order to become ice, then I would say it would be dq. dq is the amount of heat that this thickness of ice has lost in order to become ice. Water has lost heat to become ice. Let me just say that it's dql, and that much heat dq is conducted through this thickness of ice to the outside atmosphere. So all of that ice, all of that heat that this ice gave away has been conducted to the atmosphere outside by means of conduction. So the amount of heat conducted, I shall write it as dqc. Now what is the heat dql, the heat that this layer of water has lost in order to become ice? It's simply tiny amount of mass multiplied by latent heat of fusion of ice. I've just written it as dm into l. It's equal to the amount of heat conducted is dq through this thickness, which is dy, which is y, sorry. So we have the thermal conductivity of ice, the formula Ka divided by L into delta T multiplied by T. So that's what we're looking at. K into A, my dear friends, is the area of the lake here. In this case, it's a lake. So let's say the area of the lake is A, divided by L. L means the length through which the heat escapes when it's getting conducted. So this is Y, the length is Y, multiplied by difference in temperature. I told you we have assumed that this is at 0 degrees Celsius and that is at minus T. So the temperature difference is T, multiplied by time I shall say that is dt, because dt is the tiny amount of time in which that heat has escaped to the outside surrounding. You can write this tiny mass dm as density into tiny volume. Volume of this thickness of ice that has just formed can be written as area, you see, that area multiplied by dy. So I shall write it as a into dy into the latent heat equal to thermal conductivity of ice multiplied by area of lake divided by thickness of ice already formed, and the temperature difference is T, and the time it has taken for all of this to occur is dt. We have A and A getting cancelled. Now what is dt then? Dt would become equal to, dt is the time, and dt would become equal to rho into L divided by K, right, into T multiplied by Y dy is all you have. That's dt. Now, once you've written this, dear friends, you can now go ahead and find the total time that it takes for the thickness to build from y1 to y2. Let's do that. When you do it, you have T equal to, I'm sorry, we have T equal to rho L divided by KT into integral of y dy, all the way from y1 to y2. What I mean is T is the time that is taken for the thickness to build from it being y1 to another thickness y2. So we are calculating that time. When you integrate this, my dear friends, you will have a rho L divided by 2 kt, because integral of y dy is y square by 2. I've written it there. I have y, and it has to be evaluated between the limits y1 and y2. Now, what does the thickness of ice become equal to? I shall write the final statement here. I mean, the time it takes for a certain thickness to form is T. It's equal to rho L into y2 square minus y1 square after applying limits, y2 square minus y1 square divided by 2 kt. Now, this, my dear friends, is the final answer for the amount of time it takes for this thickness of ice to form. So, one little bit of information before we part, answering why this these fish you see here didn't die when all of that water was freezing is because, do you see that the time it takes is directly proportional to y square? That means y is proportional to root of t. That means it takes longer and longer for the same thickness of ice to form. So if 1 centimeter formed in a day, then it will take longer than a day to add on another centimeter of ice. So it has been, the ice has been forming on this planet. Maybe now it's melting because of global warming, but otherwise, until humans' intervention, most probably all the time the ice was only building up. And even though it has built up, it has just built up around 3 kilometers, and the aquatic beings inside are still safe. The process of formation of ice under the water goes on slowing down as and when the thickness of ice becomes greater and greater. This is the reason why Mother Earth has been able to save all of those aquatic beings. And you also know that water is densest at 4 degrees Celsius. So all the very dense water is going to be here, keeping the aquatic beings, if not at 0 degrees Celsius, but at least at 4 degrees Celsius. I mean, 0 degrees Celsius would be too cold for all of these. Mother Earth has been guarding all of them all this while. Thank you so much. It was great speaking to you. I'll be back with another video.